Spike2, along with a suitable 1401, is generally used as a chart recorder for continuous recording of waveform and event channels. A waveform channel is a representation of continuous analog data, such as an ECG or respiration recording, sampled by an ADC input port on your 1401. In this tutorial, we will concentrate on sampling waveform channels. Event channels represent timestamps, the pulse output of a stimulator connected to a 1401 digital input is a common example. Wavemark data is a special data type that combines a timestamp marker and identification code with a small section of waveform data, and is used for discriminating single and multi-unit spike activity. The sampling configuration dialog, available from the Sample menu or the toolbar icon, sets the parameters for a new data file. The Channels tab holds the list of channels to record. Any existing channels in the list can be edited, duplicated, or deleted. The Reset button clears the configuration to a basic state. New channels can be added using the associated button or drop-down. The drop-down arrow can be used to preset the channel type in the Channel Parameters dialog. Channel sets the channel number in the data file, which is displayed on the left of the data. Type sets the channel to be a waveform, event, marker, or wavemark. The 1401 port drop-down sets which port on the 1401 to use for this channel. With a waveform channel, these are ADC input port numbers on your 1401. The ideal waveform sampling rate sets the desired sampling rate for the waveform in Hertz. As a general rule, this should be set to 2.5 times the maximum frequency present in the signal to produce a reasonable representation. For example, a low-frequency signal, such as a respiration trace, would typically require a sampling rate of 10 to 20 Hz. An EEG signal would normally require between 250 Hz to 2 kHz, depending on the features of interest. And an extracellular recording of action potentials would usually require around 25 kHz. Units sets the y-axis units displayed for the channels. Standard settings are volts. The scale and offset fields are used to scale the input voltage to user-defined units for the data file to display. To change the scale to millivolts, for example, you would simply scale by 1000. Clicking OK adds the new channel to the channel list. The ADC rate field shows the actual sampling rates that Spike2 will use, which will be as close as possible to the requested rates. The ADC rate and time resolution settings for sampling are found in the Resolution tab. We will cover all of the settings in this tab in greater detail in future videos, but for quick start optimization, you should first set the type of 1401 field to match the 1401 you are using. In Spike2 version 8, the default setting is to sample to 64-bit data files, which allow both high timing resolution and long run times. If you need your files to be compatible with older versions of Spike2 or other third-party software, you can set the file output to the old 32-bit format. If using the 32-bit file format, set microseconds per time unit so that the longest runtime setting is at least as long as you want to sample for. If sampling to a 64-bit file with no time limitations, you can set this to the smallest value that gives the waveform sample rates you need. The keyboard marker channel is always available and can be used to enter key presses as markers in the recording file. You can use the Copy as Text and Log buttons to record your sampling configuration settings to a text file or the log window. By default, data files in Spike2 are created with space for 32 channels, for backwards compatibility with older versions. You can change that setting here if more channels are needed. Clicking OK will store the current state of the configuration. Run Now will open a data file ready to sample. Sampling is controlled by the sampling toolbar, where you can start, stop, abort or reset sampling. When stop is pressed, the sampling configuration is updated with the current settings and saved as last.s2cx, which will be used by default for future sampling. You can save your own configurations using the Save Configuration As option from the File menu, and load your own configuration files using the Load option. I hope this tutorial has given you a useful introduction to sampling waveform data.